You know, there's no Chrome. There's very few distractions from the content. It's just me and my ideas. There's only one problem with a pen and paper. It's not dynamic. And to quote my colleague Shimon Kaliski, we yearn to sketch in a dynamic medium. What we want is to have all the immediacy and expressiveness of a sketch pad, but the power of computation at our fingertips. This is a screenshot from a project we did called Crosscut. We'll talk more about that later. So at Ink and Switch, our interest is in tools for thought, sort of carrying on in this Engelbartian tradition. And we're really interested in how to make computers more powerful companions in our thinking. And so to that end, I want to talk a little bit about some of our design criteria that we apply in developing tools for thought. And we're going to tie this back into live programming, I promise. First, we feel that thinking tools really must be responsive and predictable. You know, like a good chef's knife, this is maybe more fancy than a chef's knife I would recommend, but like a good chef's knife, you know, to a skilled practitioner, the knife is not so much a thing that you hold as the edge of the blade becomes an extension of your body, right? And a dull knife is dangerous. If you tried to move a knife and it delayed sort of 200 milliseconds, well, that would be a sure way to get yourself into trouble, right? So a good thinking tool should be like a good chef's knife. It should be responsive and precise. It should be predictable. It should go where you take it every time, right? If the knife one time in 100 slips, well, that's how you end up getting stitches. Thinking tools also should be dependable and durable. It's not enough for it to work on your desk, right? You should be able to take that pen and pad with you to sea, to the office, use it in a taxi, right? Paper journals from thinkers of past generations are still legible. You could still write in them. That would probably get you thrown out of the Smithsonian, but you could, right? Software tools are tied not just to, you know, current versions of operating systems, which is certainly one thing, but they're also these days also tied to a network connection, which means that there are many places we go to think and to work where our tools can't come with us, and that's a tragedy. Thinking tools also need to toe a difficult line between, or walk a difficult line between being collaborative, but also between being private. We're going to return to this theme later, but I'll just note for the moment that creativity is not a solitary exercise in almost any circumstance. It involves lots of different participants with different skills, with different perspectives, and we both want to share and collaborate, and we want to step away and have privacy to think. And the digital tools that we're building today mostly force us to choose between one pole or the other. And kind of last, I believe we need tools that are specialized but broadly useful, right? We heard yesterday in Paint about the idea that maybe we need different languages for different tasks, that sort of the one language to rule them all model is not the future. I feel similarly about thinking tools. When you go to a show, you go for a performance. Now, if you are a classical musician or in a rock band, you can hit the drums, you can play the guitar, but of course, software performance, one of the original inceptions of this workshop, came from the live coding community, people who perform software live on stage. We're going to see, I think, in the closing of the conference, we'll see a live coding musical demonstration. And I've got sort of three representative examples here. On the left, we have Imogen Heap wearing the Mimu gloves. This is a tool that she uses. It's sort of an expressive instrument that she uses to manipulate live programs that she's helped compose. In the top right there, we have Cycling 74's Max MSP, which is the granddaddy of all node and wire programming languages. And underneath it is, has anybody here seen Orca before? Okay, one person, two people. So Orca is an esoteric programming language developed by 100 Rabbits. It's sort of like a cross between Ableton Live, MIDI generation, and a roguelike. So the state of your program is visualized in ASCII on the screen, and it evolves over time and emits MIDI events. The reason why these live programming tools are successful in this context is because the value of performance, the virtuosity of watching somebody create live in front of you, is what you get by going to the show, right? It's not fun or exciting to go to a show to watch somebody perform a composition by like typing in /play, enter, and then just standing there. Similarly, Max Bitker introduced me to the Roblox programming environment, which although it looks much more like a traditional programming environment, it's actually operating on a centralized cloud service. And so you have a live programming environment where you're building systems together with other people. And of course, again, because this is sort of like a slightly Wild West youth-oriented environment, the first thing you do when you want to find, like, I don't know, a horse to add to your little game you're making is you search in the search box for horse, and then you drag it into your scene, and then you have to open up the object and look through it to see if anybody's snuck any scripts in there that are gonna like play pranks on you, because that's a common thing apparently to happen. So everybody knows in that community, when you import assets, the first thing you do is you go and look through to make sure nobody's hidden anything inside. The last example that you could do a whole talk here about Dreams, but Dreams is a live collaborative visual coding environment. But Dreams' programming model is a lot more like, in some ways, what we're used to. Yes, it's a live programming environment where you can sort of open up objects and put together little circuit flow diagrams and so on to build logic. But the sharing model actually looks a lot more like maybe what we're used to as professional programmers, which is you build assets and then you share them and you update versions and publish them deliberately over time. So again, different sort of points in this space. Now, it wouldn't be a live programming workshop without a slide showing a spreadsheet. So yes, spreadsheets, that's a live programming thing. I was telling someone earlier that I think, personally for me, spreadsheets are not that interesting. I think there are so many places that we could be exploring live programming and building lively systems that I think are less mature and are more open to experimentation. But while we're talking about sort of professional live programming, I want to point out that I feel, we're going to look at the definition of live programming within the context of the workshop, but I feel like actually bash programming and SQL programming share a lot of the characteristics of live programming. So let's look here. We've got live programming gives the programmer immediate feedback. Yeah, I mean, unless you are, if you're operating on a small database, certainly you get that from a SQL prompt. The program is highly structured and meaningful even in traditionally invalid states. Maybe, I think so. Programs that make execution transparent, tangible, and explorable. I certainly feel, if you watch an analyst working live and interactively with a SQL database, you see all of these techniques and tools people use to build up complex queries out of subqueries. I think that qualifies. And it very much is about starting with concrete examples and generalizing from them when you watch people working in these environments. And so I think it's interesting to kind of consider, we could improve those systems dramatically, but the way that people work with those systems, the way analysts work with those systems, systems modelers work with those systems, meet a lot of these criteria. Now, on the other hand, where are we not finding life? We know on Earth you can find life almost anywhere if you dig. This is, I forget which asteroid this is. Enterprise software is anything but lively, and I'm going to pick on my former employer, Salesforce. They have no software, they'll be the first to tell you. I don't think I entirely agree. And I'm only picking on Salesforce because I used to work there. They are not really any different than anyone else. But one of the sort of interesting things about Salesforce is that actually building and working on Salesforce itself is basically torment. It's like a multi-hour build process from a fresh build of some monstrously huge jar file. It's sort of well known within the organization that it's okay to build every day because you can keep up with changes, but if you try to build it every other week, it's impossible because the build will have broken for you and then it's going to take you hours to fix. And it's just this really miserable experience. unwillingness to invest in liveliness and a prioritization of risk avoidance. Ooh, I'm looping. This will be for the live coding demo later. And besides, you can't really fit everyone's ideas into one code base anyway. Like, you shouldn't let people produce software. If you're an organization that has software people are paying for, the worst thing you could do is just add a bunch of extra stuff. Everything you add to a project takes away from everything that's already there. It dilutes the value of existing things. So really in a big company, a lot of what you're doing is basically defending the core value of your product and trying to add little bits around the edge to gain more customers. I think as compile and debug cycles grow longer, we move away from live programming, but the software hasn't really died. And so I would like to propose that we consider these sort of undead, neither living nor dead programs as zombie programs. And at some point for an organization, you may be beyond help, right? There may be no coming back if you put off this work for too long. Because the cost of restoring liveliness, even though all the participants in the system might agree, yeah, it would be nice if the system was more responsive, if we could work. No one who's working on these gigantic, monolithic enterprise systems is happy, but the work it would take to make it better relative to the organizational value of that investment may not be there. And so they linger in the twilight. Anyway, let's talk about our research a little bit. So a lot of our work intersects with live programming in a variety of ways. We have sort of three major areas of work right now at Ink and Switch. We've been exploring programmable ink, we're looking into malleable software, and we have another track of work called local first computing. And we're just gonna kind of find our way through all of these a little bit and talk about how they relate to live programming. So let's start with programmable ink. This is, on almost all of this work, I will be reporting the work of my colleagues. I'm going to do my best to represent them faithfully. I asked them all for notes, and if they're watching the recording of this later and I flubbed something, I'm so sorry. But anyway, we have a number of experiments in sort of programmable ink, which is to say drawing software. And the extent to which this is true varies from project to project. Some of these have been presented at past live workshops. I'm not going to belabor them too much. This is Inkbase. Inkbase is a system where you draw things and then you can use sort of a Lisp language reactive system to update the drawings dynamically. The next project we built was Crosscut. Crosscut basically was a response to Inkbase. We said, okay, cool, it's nice to be able to program a drawing, but no one wants to write Lisp in a little text box on an iPad. What we want was to really program with a pen and to see how far we could get that. And so this project here, Crosscut, is about drawing dynamic models. And then our most recent project, which I don't think we've published this yet. No, we haven't published this yet, so sneak peek here. It was presented at Strange Loop. This is called Untangle, and the idea behind Untangle is that we have an SMT solver running behind the scenes, and you can draw descriptions of the problems you want to solve and the rules you want your solutions to obey, and then you can interact with that solution space to try and find an acceptable solution. We'll talk a little bit more about that. And so these represent kind of different modalities of thinking about programming with ink. Inkbase was our first project, and it was really trying to find the feel of programmable ink. What would it be like to draw and compute together? Crosscut was an exploration of programming through drawing. Could we create a feeling of computation that wasn't tied to sort of a classical isomorphism to like a Python language, but something that was natively a programming computation environment derived from ink. And then Untangle is really about the conversation with the machine, right? Often when we're thinking, and when we programming is the tyranny of formalism, right? We fight the type system, we fight the compiler, we fight the runtime. What we wanted with Untangle was to sort of turn this on its head and say, we often, as we think about a problem, we don't understand the problem. Like that's very fundamental in programming as well. We build abstractions that don't actually model our problem domain well. And so with Untangle, what we wanted to do was give people tools to draw what they thought their problem was, and then to be able to, that you draw sort of some lines and boxes. Let me go back to the slide here. You draw some symbols and then boxes, and then you create assignment rules, and the system offers you candidate solutions, and then the little dots along the bottom let you select. You could just scrub through those and find a solution that you like, or you can say, actually, it looks like all of these examples I'm finding are no good because, if this is a student marking other students' papers, this is the example here, well, I obviously don't want students to mark their own papers, so we'll add a rule for that. And then it will only offer you candidate solutions like that. But maybe you add too many rules, and now the system can't be satisfied. Well, instead of being an error, we want this kind of continuous conversation. We say, okay, well, I don't have any solutions for you, but if you turn off this rule, you can have these solutions. And if you turn off that rule, you can have these solutions. And so it becomes much more of an informal dialogue between a conversational participant than this kind of like formal specification process. And we're continuing to work on this. We have another project called Habitat that we're still working on. All of these emphasize, they're all live in sort of the description we have here, but they all emphasize different parts of the problem space, right? Crosscut, for example, so in Inkbase, it's totally possible to just write, garbage text into a Lisp input box and have something that won't run. But in Crosscut, we put a lot of work into making sure that you can draw uninteresting or unuseful programs, but no marks you can make with a pen on the screen produce invalid input, maybe just unhelpful or uninteresting input. And so, this continuous program space was really a breakthrough for us because you don't have this like fight with the interpreter. Oh, how do I need to connect this to there? No, it's fine. If you have an unconnected line, it just means you haven't connected the line. It's not a program. It's just not necessarily finished yet, right? And some of the, I think, typed hole stuff that Cyrus Omar and his Hazel crew are looking at was inspirational there. And Untangle, when we did Crosscut, we sort of built this whole system, but at the end we kind of had like, a pretty cool way of doing geometry proofs. I mean, sure, we also showed how to make a drum machine with it, but with Untangle, we wanted to get away from this kind of like formal composition of strict rules to this kind of conversational media. In both cases, what we have are these visual native languages with continuous input space, but they're both designed for very different and specific problem-solving activities. We don't think that these two tools themselves represent the full toolkit for the workshop of the mind, but we believe that in both cases what we have is something that could be broadly applicable, but is also specific to a particular task. And we're interested in finding more of these, and also in creating an environment which could host a variety of these. But of course, putting the pieces together is hard. And more than that, it's not clear to us how far these things will scale. These are not Node and Wire languages. Shimon insisted that I point out that we are not building Node and Wire languages. But Node and Wire languages have similar challenges, which is that as you scale them, you have something that looks quite a bit like sort of literal spaghetti code here, right? And these systems can become quite unintelligible. This is a screenshot from Julian Otavi's, and underneath it, this screenshot was posted in 2015 with the comment, "I will organize it sooner or later." There have been no updates in the intervening 7 years. The other thing that you don't see in any of our examples, right? We sort of have the luxury so far of operating in this space where you're modeling, you're drawing or creating all the data within the system. We think there's obviously lots of different and exciting use cases where the data exists outside the system and you want to bring it in, right? And that's a separate set of tools and problems we want to explore. There's lots to do. I'll just leave it at that. On another side of the house, we're looking at what we call malleable software after Chernovsky's thesis. And this is Jeffrey Litt and Paul Sonnentag and others. And malleable software is software that can be modified by its users in the field, right? This is not just open sourciness, right? In fact, you could have malleable closed source software, or you can have totally static monolithic open source software. But rather software that's reconfigurable or adjustable during use. And Chernovsky in his thesis says, the goal is to erase the boundaries between apps and create an end-user accessible physics of interfaces that dictate how different interfaces and documents can be assembled. I just love this. It's really about ending the tyranny of the app as like a closed space, and about opening up an environment where we can all be more generative and put the pieces together in ways that suit us. And if you don't believe this is a problem, try and get a note from Apple Notes into Dropbox or Notion or something else. You're going to be using copy-paste, and it's probably going to screw up the formatting. Now, this software does exist, and in fact, most of us in this room live in this world, right? If you got to a new job and they were like, okay, welcome, your IDE is this. Oh, are you familiar with Vim key bindings? We don't do that here. We use Emacs key bindings. Don't worry, you'll get used to it, right? I think you'd have a hard time recruiting for an organization that imposed that kind of tooling on developers. But we certainly live with everybody, you know, your employer or your group or whoever could choose to adopt Notion or Google Docs or something like that, and you're back in this space. So we have this like interesting dichotomy where developers have access to this kind of malleable software. Visual Studio Code has a whole ecosystem of extensible tools, and of course, you know, I can't show a modern IDE like VS Code without also including screenshots of Emacs and VI. Yes, Emacs is a great operating system, and someday you will develop a text editor for it. Good luck. But the sort of deeper question behind this is, like, why do we need an app for everything? Right? This screenshot here is from a blog post called the 30 Best Workout Apps of 2022. But I could basically guarantee you that none of these are right for you. And we're going to hear from Jeffrey Litt, actually I think right after this, who's going to talk about an experiment we did in malleable software called Potluck, which was about building dynamic documents as personal software. And the insight there was like, actually, you're just going to put all your data into Apple Notes anyway, so how about we just program there? But I'm going to move on from this pretty quickly because Jeffrey's going to talk about it and I don't want to get too much into it. And so I want to talk about kind of the third leg of the stool for us, which is this local first software concept. And I'm actually going to talk about journalism for a while first. So in writing, we have this nexus that I mentioned earlier, where we have to combine both creativity and collaboration with formal change management and expectations of creative privacy. And none of the sort of existing poles of collaboration software are well suited to this task. So at one end of the spectrum, we have the kind of like, everybody's in the same sandbox, live authoring, right? Truly live of like Google Docs, so live that it doesn't work if you turn off the network. And at the other end, you have this like very formal asynchronous collaboration through, you know, GitHub PRs and all the sort of Baroque formal tooling around that. But, you know, if you're the New York Times, you know, you need to get to print fast and you need to get to print right and you need to do it every time because otherwise you're going to get sued for libel. Right? And if you're too slow, you're going to miss the scoop. And if you make a mistake, you're going to get a source jailed or killed. Right? There's no room for error. And so the New York Times has a need to have both accuracy and speed in the newsroom. And because they have 2,000 journalists, they also have the budget to build a tool for them. Or maybe it's just because a lot of people pay their New York Times subscriptions. But regardless, they have enough budget to have built this wonderful tool here. It's called Oak. It's their in-house editor. It has a lot in common with Google Docs, but it introduces a lot of extra procedural workflow that suits the New York Times editorial policies needs. So it includes tools that allow an editor to look at a document and see how it's changed, you know, definitively, and to be able to pass it through their sort of editorial process and bring it out as a piece. And it's very much, you know, a piece of cloud software. It works really well at the newsroom and in the offices when you have a fast Wi-Fi connection. But what we've heard is that, of course, it's built on OT and it's part of this generation of cloud software. And so journalists in the field find it can be quite frustrating to work with. because they don't have a fast Wi-Fi connection, because, they're in the field, they're in a cab trying to post a story on the way back from wherever they were. There's lots of reasons why this might not work. And also, there are trust issues. It's in-house built software, and it doesn't anymore, I'm told, but historically, earlier versions would occasionally eat a little data now and again. And the number of times as a journalist that you're okay with that happening is approximately 0. And so once you've broken trust, it's very hard to get back. And so, this sort of cloud tool is both a great asset structurally, but it's also kind of a liability because it's built on this always online kind of mentality. And yes, it has change tracking, but it also means the editor can hop in and see what you're typing right now. And not everybody wants to be surveilled by their editor or their boss. I don't know how many of you have worked in big companies, but what we've heard from talking to designers in our user research is that when the VP of design, a little circle icon pops up in the Figma doc, everybody stops what they're doing and looks to make sure they don't have like weird, ugly things on their Figma doc. Now we have at the other end of the pole this Git and GitHub model, just setting aside all the user experience problems there. This is also not really what you want in a lot of cases, right? Like, programmers I talk to frequently are trying to figure out how to get that Google Docs experience built into their IDEs. There's VS Code Live Share, or you can, abandon all modernity and just use a tmux session and share a Vim buffer, right? Like, we're trying to get back what they have, and they're trying to get what we have as developers. But in all cases, what you see if you study users in the field is that there is not one tool that supports both of these modalities. And so you see a lot of like really awkward workarounds where people are like copying and pasting things, or like, why am I have a Git session, but Git can't do live collaboration, so I'm using OT to a live cloud server to share my VS Code buffer with you that we're editing in, and then it desynchronizes. Like, how is this possible that we haven't solved this? And when you look at this in kind of a structural way, what we see is that when latencies are small, we consider this live. But like, what is live? Like, there's more than one thread here. There's more than one computer, right? There's a network involved. You're not really live. You're just low latency. And so if you see like a merge error in OT, you're just like, oh, well, it's just a typo, right? Like the problems that accumulate at, sub-second scale, you just sort of view them as user error more than system error. But of course, as the time window expands out to say 30 seconds or so, if you submit like an edit to a GitHub issue or something to fix the title, and somebody else also noticed the problem and fixed it at the same time, you don't really view this as like those distributed systems people should have solved this problem better. You're just kind of like, oh, I need to redo this work. It's almost an unconscious sort of thing. You don't reach for a tool to help you. You don't go, oh, I should have checked this into a repo somehow. You just fix it. And again, this is sort of observational. But as you sort of go beyond this, like, say, 30 seconds, maybe it's 5 minutes, I don't know, it's going to vary by the person, out to a longer time scale, all of a sudden now, in a sense, nothing has changed, right? This is all, like, from a computer science perspective, these are just changes occurring in a distributed system. But the expectations and the needs of the humans in the system change as the timescales expand. And so that's why we have all of this elaborate pull request machinery, comments, feedback, reviews, and so on. You would hate it if on every keystroke you had to do a PR, right? But at the other end, you would also hate it if when somebody refactored the whole project and you turned on your machine, it just showed up in the middle of your patch. Good luck. Especially considering that our diff algorithms don't even understand source code. They just operate on lines of text, and even that, not very well. And so one kind of takeaway I hope you'll take from this is that live and public are not the same thing. I may want to have a live collaboration with one person, but keep that work private from somebody else, either because I'm not ready to share it for personal or sort of emotional reasons, or simply because I don't want to disrupt what they're working on. And so as we explore these live systems, we should be mindful that liveliness is not the end state, that there's a lot to be desired about asynchronous collaboration. And vice versa, when we look at people working with existing robust live systems in the tech space, they want the benefits of the asynchronous collaboration. So we need to build models that respect both of these goals. And just to sort of drive home the misery of our actual lived experience, when we write our essays, we usually begin in Notion, then we export to Markdown and paste them into like a text buffer and commit them to a Git repo to get a first look at the essay. Then some folks in the lab will read it, but of course it will be bad because it's a first draft. So they'll have all kinds of comments, but you can't comment on a Markdown file in a Git repo. That would be crazy. Why would that work? So what you do is you select all the text of the Markdown and we paste it into a Google Doc. So then we have the Markdown in the Google Doc so people can comment on it and edit it. And then once that process happened, then we bring it back into the Markdown and then compile that to HTML, which eventually makes it to the essay. But you can see here, this is one of the essays we're working on at the moment. And there's like a to-do popping up in the bottom right there, which is just like a comment, but there's no real support for comments in Markdown, so somehow it's made it through the final HTML. This stuff is maddening. We have a paper coming up called Upwelling talking about some of these problems and how we propose maybe working on them. And so when we talk about live software, and when we're in an environment that's professional and we want to be both fast and correct, it's not enough to just provide liveness. We want to have live building, we want to have immediate response to our actions, we want to have live collaboration, but we need deliberate sharing too. We need to be able to say, I'm not ready to share this with everyone yet, and now I want to share it and get comment. I want you to be able to see what's changed and review it. And similarly, I can't really imagine working on a serious production system where like every change I made was going straight live to production. That's crazy. Or at least there are many contexts in which that might be undesirable. Let's use more less ableist language, but also more precise language. There are many times when you want to be deliberate about how and when you distribute software. And in fact, we have been exploring sort of a technical dimension of this in partnership with Martin Kleppmann through the AutoMerge project, which is an application CRDT. This charming little diagram from one of Martin's talks shows that on the right there, you can see sort of what's a traditional kind of like reactive document rendering model. You take a document, it renders to a user interface. You modify the user interface by interacting with it, which produces changes to the document. So from a local perspective, you're just editing your own thing. But of course, you can also transmit those changes over the network to other places. And because we separate the synchronization of program state from updating program state or rendering it, you don't have like complex APIs that need to be reasoned about. As long as your document is designed in a way where edits can be combined, that's, let's just say, a big asterisk. And there's some folks around here who are thinking about these problems. Anecdotally, though, it seems fine. That's a very weak form of defense. We could talk more about that some other time. But it's really beautiful to be able to basically just write software locally, and it allows us to center a really crucial user experience value, which is that no matter what, you should never stop the user from making progress in their creative work. No matter what. That's a core belief. And it means that, you know, if you could get the program into an invalid state because different people edited different things, that you have to accept that risk and then figure out how to recover from it, because you must never stop the user from making progress. It's their computer, it's their creative work, it's their thought process, it's their device. They should never be in a position where their software doesn't work because they don't have a network connection. Or because somebody else has, you know, locked a document. You know, it's a very different take on software development, and there are many domains and applications where this is not a value people hold, but for our work we do. And this isn't all theory. This is my notes for making this talk. This is a program we call BlueTack, and it's based on these ideas. Each of these cards you see there is a transcluded text note on a spatial canvas, and on the left you can see a list of the notes I was making as I was writing this talk. And this is a local first application. All the data lives in IndexedDB. As I make edits, I can share a link to this view with a colleague. And when they open it, all the data is downloaded from the sync server that we're syncing live to when we're online. But if I'm offline, of course, that's fine. The changes just accumulate locally until I come online, at which point things sync through. There's a lot more work to make it good, but it's good enough that I use it. I actually use it, right? Like this is a non-trivial milestone for us. And so the kind of basic idea behind this sort of local first lifestyle is, we want to keep both the data and the code on your computer, and you get something that is lively, if not fully alive, when you can sort of have a React component program open in your VS Code on one side, and then a live running program on the other side. And as you edit it, you don't have this kind of like, oh, what's going to happen when I push to prod? Am I going to have to run a database migration? No, it works on your machine, so you're done, right? And it's a really powerful feeling to develop software that runs on your computer and lives in your computer, because you don't have this kind of like, okay, well, I got it working on my computer, but now I have to figure out what this looks like to take to prod. Your computer is the deployment environment, and if you want to share it with other people, you can. No daemons and no Docker required. So in the case of BlueTack, which I showed you, it's, we're still kind of living in that realm of live editing, but in fact, there's no reason why you couldn't put all the source code, or almost all the source code for that program, into itself. And then you have something that's very small-talky, very croquet. And we tested this. Unfortunately, I can't show you because I built it as an Electron app with a bunch of binary node dependencies. And like every 6 months, I try and recompile it all, and I spend 2 days on it, and then I go, okay, fine, I give up. But hopefully at some point in the future, we'll be able to prove this. But for now, please just take my word for it that you can, in fact, put a React component and evaluate it at runtime into a CRDT. Certainly you could do a lot better than that, but like as a starting point, it feels pretty great to be able to share a link with someone. And it's like, you're used to this, again, kind of like, okay, well, we've got this live collaborative environment, but if you want to get the updates, go check it out of this asynchronous collaborative environment in GitHub and run a build process and then run it locally. It's like, well, let's just put the code in there too. Feels good. All right, so I've harangued you enough. Let's recap briefly. We're interested in tools for thought because we yearn to sketch in a dynamic medium. We want more than just these dead trees, covered in ink, but we want more than just dead pixels too. We want to be able to sketch and think with our hands on our computers or on some computer in the future. We believe that malleable software and this kind of local first ethos, if we can move the complexity out of this model where every feature has to go into every version of the application and allow people to customize software to their needs, we believe that we can simplify and make a lot more humane a lot of the tools of software that are out there. And I offer as evidence the ever-evolving ecosystem of Emacs usage or VS Code or any of these things, right? I don't have to absorb the complexity of like people who are into Haskell or Elm programming if I'm not into that, but I can choose to opt into that or like crazy parenthesis highlighting or whatever features I want based on my needs and my preferences. Whereas if I use Slack and some product manager decides to add rich text editing that I don't like, I gotta live with it. So this is not like a hypothetical thing like, oh, we should be able to do this. We're doing it, we're living with it. We need to give it to more people and do it more often. And the last point kind of on this line is collaboration is fundamental to creativity. And when we're building live programming systems, we need to understand this. And collaboration doesn't just mean slam all the changes together and hope for the best. We need more sophisticated understanding of collaboration primitives in live programming environments. And I'm really hopeful that maybe next year some of you will have written papers about this that I can come and see. All of the work that I've shown you is part of one kind of unified program that we're working towards. But most of it does not implement all the different pieces at once. This is just sort of like a survival strategy for us. If you tried to build all these things together, none of them would work. You know, the idea is we pursue these things independently in order to actually decouple them and make them less expensive to explore. figuring out how you put together live programming with local first software and malleable systems is, well, it's left as an exercise to the reader. Or, well, probably an exercise to us. And just as some like high-level takeaway, you know, small programs are often lively. Like liveliness is something that we begin with, but we let get away from us as programs scale, either in complexity or in terms of the amount of data that they work on. And we can think of those as zombie programs, no longer living but not dead. And we can avoid this fate by being strategically small. Right? I know Yoshiki's system has these micro worlds. You know, you decompose a big complicated system into small pieces and you don't allow them to talk too much to each other, and that can help you keep things manageable. And I will leave you with this wonderful quote: "In spite of the cost of living, it's still popular." That's all. So I think we have still a few minutes for questions. Yeah, happy to take questions.
Hi, thanks for the talk. That was very interesting. More recently, there's been like work in like Notion has like added like AI and these like Copilot and this, where there's like a kind of interactive sort of dialogue between like human and machine. But how do you feel like the about the, well, of course, there's like the implication that these are running locally and they use it machines and this. But can AI like play these roles, or does it have to be?
This is a great question. So we talked earlier about my belief that tools should be predictable and responsive. I think AI makes a great collaborator, but you know, and I would think of AI, if you want to use a kitchen metaphor here, AI would be a great sous chef, but a poor kitchen knife. Right? So AI you can delegate tasks to, you can review the results, but it's a collaborator. And the way I would model it in a system like this is as a co-author rather than as a tool. Now, I think we're just in a real phase transition right now in terms of what AI is capable of, and I reserve the right to be wrong about this, or all of it, really. But I think that in terms of thinking about how to integrate AI, I would think about it more as you can imagine AI as another author in a document. And in fact, that's sort of what we see with things like Copilot, right? You sort of tab completion and it types code in for you. One thing we think a lot about is how to differentiate between what we call computer voice versus user voice. So we want things that are not user authored to have a different vibe than things that are user authored, so that it's clear what the history of the document is and what systems were making which contributions. Now, to come back to always online and whether these things imply the cloud, yeah, sure. In a sense, you could think about this in a couple of ways. One is that there's nothing about AI that implies it can't run on your machine. If you've been following the huge progress that Stable Diffusion has made lately, I think that the reason AI models are expensive to operate has a lot more to do with just being early and people not having done the hard work of optimizing those systems yet, rather than something fundamental or intrinsic to AI. However, I also believe that these AI models are viewed as strategic corporate assets, and so they'll be closely guarded. Another way of looking at this is that if AI is a collaborator in a document, look, if you're offline and Copilot can't fill in the code for you, you might be annoyed, but you should still be able to type into your program. Right? And when you come back online, maybe Copilot will look at your code and go, well, I don't know what you were doing, but you shouldn't have done any of that, and make recommendations, just the same as if you had a colleague review your code. So I think that I think how I would approach that problem today. I'm very excited about what's happening, and I'm eager to see how these models interact.
Yeah, so one of the ways that programmers are able to collaborate and share things is it's enabled by the fact that we have a lingua franca of kind of plain text files that we're able to share with each other, or at least copy and paste, and don't have to worry about formatting being obliterated. But the thing with like end user apps is that lingua franca either doesn't exist, or these sorts of things you need to share are richer than plain text, and that's a problem. So. And you've got copy and paste, and it's kind of the technical basis for the app is kind of the Unix process, right? And so you're looking at inter-process communication, and programmers use text files as this. And for an end user, you're kind of stuck with copy and paste, and that's it. So that seems like a bigger challenge. And are you optimistic that something can be? Does this not overcoming this not rely on a new standard or something?
First, copying and pasting code between Go and Python programs is rarely successful. I don't think there is a lingua franca. I think that a lot of our tooling, I agree, is based on the 1970s notion of plain text. Plain text is a terrible API, and the POSIX file system is worse. It's semantically impoverished. It's highly contended what it means. It has all kinds of problems. I believe deeply and fundamentally that the next generation of computing systems must be built on a new primitive. We believe that that primitive is change, and that's why we're investing so much energy into CRDTs and efficient binary formats and synchronization protocols, as well as other folks like Kevin Yantz with the YJS project and Joseph Gentle with his diamond types and various other people around the world. I don't know if this work will be successful, but I do believe that no one has cracked it yet, but I think that the end of POSIX is probably between 5 and 200 years out, but I hope to live to see it.
Yeah, me too.
Could I ask about, it seems like you're...
I'm going to pass the mic down, yeah.
Thanks.
So it seems like really cool projects, and it seems like most of them are kind of like, built on an iPad or built, into your editor or something. I'm curious if you see any, are there any hardware features you wish you had? Like, is the iPad kind of the perfect device and we just need to get the
iPads are
software
terrible.
Okay.
Let's see. iPads have glowing screens, which aren't great. We think e-ink is promising, but obviously e-ink has all kinds of latency problems. I saw somebody had a Remarkable in the room. Yeah, there's one. Is that the Remarkable, or is that a...
Remarkable one.
Yeah, so those are great. The Remarkable has latency problems, e-ink has latency problems, but people are continuing to work on that. I think there's a lot of interesting potential there. We've explored that a little bit. I think that pen latency generally for stylus-based computing has been a huge challenge. Nominally you can do stylus-based computing in the browser, but not really, because the browser just eats frame after frame after frame. We have a motto at the lab, which is results in the next frame or your money back. And the idea is for local first computing, you can never make cloud software fast. We're in New Zealand right now, so people who live here already know this. But the internet is not really this thing that exists all around the world. The internet actually lives in Ashburn, Virginia at US East 1. And if you don't live, a 10-minute drive from there, latency is a problem. So if you want next frame latency, if you want tools that really respond on the next frame, you got 10 milliseconds. I live more than 10 milliseconds from US East 1, and that means that unless you're writing local software, you're just faking it and trying to hide the lag in the system that you've built in. And so I really think just from a usability and performance perspective, we need to start moving to a model where the software lives inside our computer by default and we synchronize when we have to instead of the other way around.
Cool, thanks very much.
I have a question related to the programmable ink tools.
Sure.
It looked like that it's primarily about computation, like how can I express some forms of computation with these tools. I was wondering whether how the role of data plays in here. So because usually if I'm thinking about note-taking, it's the data that comes first. I want to have a space where I can put valuable information, organize it, and put in some functions, whatever, only in the second. So what's your take on this?
Yeah, we just recently published the ink-based paper, which talks about this kind of thing at length. But that's very much what you see, like in this example here, which is, you start by drawing things and then you enrich the diagram over time. Many people have this habit with Excel spreadsheets, which is sort of like the first version of your Excel spreadsheet. You just type in some data, and then you gradually enrich this this system over time by adding functionality. And we see the same opportunities in this sort of stylus native computing environment where you just begin by drawing something for yourself or making a note. And we talk about like a Seinfeld calendar, right? You draw a calendar and you just start writing X's in it. And then at some point you think, well, how many days is my streak now? Right? And so now you sit and you write a little script that adds that logic and shows the number on the side. But you don't need to do that ever if all you need is the image. And so similarly, there's some kind of dubious, quasi-made-up statistic that's like 90% of all Excel spreadsheets don't have any formulas in them. But that doesn't mean that people don't get value from using Excel, right? Like, Excel is kind of a drawing program for numbers in a lot of cases. So I think, I think I would maybe go one step further and say there's also really interesting questions about bringing data in from outside the system, which none of our experiments have tested. I could tell you what I think, but it wouldn't be supported by any work, and so I will say simply, hopefully we'll get around to exploring that at some point.
Thank you.
We have a question from remote.
Yeah, remote question.
Oh, here you go.
I think they might be.
Jonathan?
Oh, Jonathan. Hi, Jonathan.
Jonathan, can you hear us?
Yes, somebody might muted.
We hear you.
Again. Okay, thanks for, Peter, for this. Very interesting. I especially liked your call for that liveness must also include collaboration and asynchronicity. I think that's something we've really needed to add to the live programming research. So I would just like to ask you, in your future utopian vision of live cooperative programming, is that done on top of JavaScript and React?
God, I hope not. Okay, I think that the future will not be one thing.
Audio's out again?
No, we hear you, Jonathan. Yeah. So just to make sure I understood the question you asked, do I think that this live collaborative programming utopia will be written in JavaScript and React? I mean, I really hope not, but I think that a successful system has to decouple, like if something is really gonna have like civilization scale impact, which, you know, I'm not saying this will, but if you really wanna have a big impact, I don't think it can be a vertically integrated solution that's tied to a single programming semantics. We talked earlier about sort of the belief that, you need lots of tools for different purposes. I think the same will be true here. I really hope that the day in my life comes that I'm not writing a JavaScript dialect professionally anymore, but I'm not holding my breath. But I think that...
Well, can I...
Yep.
Can I refine the question then, which is the research path to get to this utopian, does it involve going through inventing new programming languages and paradigms even in order to see how to adapt the existing legacy tools? Or can we just skip that and just make it work on top of JavaScript and SQL?
I think this is an empirical question. I would like to try modeling JavaScript programs in a CRDT in an AST representation so that we could try and do meaningful merges of those programs. But that seems hard. I know Cyrus Omar has some thoughts about representing Hazel's language as a CRDT. Maybe that will be easier. I mean, it would be a bit ridiculous to claim what the answer is when no one's tried anything really yet, and I suspect it will take a variety of people trying different approaches before we sort of solve this. So, if this interests anybody in this room, I hope you'll go and try something. Or if you're already trying something, I hope you'll try and think about how to integrate these kind of collaboration primitives. I think if I have to offer at least an opinion, which is the best I can do without having tried building anything, I think that richer representations than plain text will be really helpful. I know Paul Shen feels differently with his work on Natto, and he thinks plain text is it. So, I don't there's not one belief or one right answer, and I think we just have to go try things and see how it goes.
Okay, with that, let's give Peter one more round of applause.
Thanks, everyone.
Thank you.